Hello everyone. My name is William McKeever. I'm the chairperson of the West Virginia Envirothon Committee, and I'd like to welcome everyone to our first virtual training. We hope that you can get something out of this to share with the students and pass on. This year we're going to start out with aquatics, and Martin Chris will be the first one up.
Hi, I'm Martin Christ. I work for the West Virginia Department of Environmental Protection. I have not mastered the art of wearing a mask and not fogging my glasses. So I work for the DEP. I'm in the Watershed Improvement Branch, and we're there to inspire and assist people who value and want to protect and clean up clean water. We show up when citizens say, what can I do to make our rivers and streams better? All right, so I think Envirothon is really exciting. It gets me a little teary. We're trying to help kids who want to learn how to manage the planet, and we're gonna need them. You know, somebody needs to know the difference between silt and clay. Somebody needs to know the difference between a black oak and a black birch. Somebody needs to know the difference between a trout and a bass, although I think we're pretty good for that in West Virginia. It's important. And it's also great to see the kids walk around with their noses out of their cell phones at Envirothon. All right, so it's great. There are 5 things. All right, so aquatics, we hear people say we're hard, and we like it that way. I hope all the other branches also say we're hard and like it that way. I think that's the way it ought to be. We test on 5 things, and sometimes around the committee people are saying, oh, you shouldn't tell everybody what's on the test, but we give people a pretty good idea. And that's good because we want to give these kids the message that, yes, you try, we're going to give you positive reinforcement because we like where you're headed. All right, so there are basically 5 things we test on. One is just a written test. Another is delineating watersheds on a topographic map. Another is bug identification. Bug is code for benthic macroinvertebrates. Another thing is lab tests. And the last thing is stream evaluation. I guess I'm just going to run through them. The written test. The goal is to know everything. On this sheet that I passed out, there are learning objectives for the National Envirothon. And basically, it's a long, long list, know everything. And I think the Envirothon guidelines, a lot of people look at them and say, hey, these are college classes. Is that the experience of other departments? No. All right, well, it's a long list. There's know everything. And I tacked on a few of my particular bugaboos, which may or may not be on the test. I'm not the main test writer. But it's things like, what 3 categories of features are used to identify wetlands? For what 3 reasons, name the 3 main reasons that we value wetlands. Explain the difference between pH and alkalinity. That's hard, and that's probably not really going to come up on the test. If 1 inch of rain falls on a 10-acre area, how much water is that? So the idea is just find a kid who wants to know everything and get him to know everything. To back out to sort of 30,000 feet, your kids compete as teams. So it's good for every kid to know something about everything, but if you have one kid who specializes in this and one kid who specializes in that, it's a good thing. And I am not a teacher. I've tried to teach a couple times, didn't go so well. But it seems to me the kids are going to be different, so if you can, they'll naturally gravitate to specializing in different things, if you can get them to gravitate at all. Okay, so I don't remember which one I said first of the other skills, but everybody likes the bugs. For bugs, the challenge is there will be 2 trays laid out, and the test will be to identify the organisms in one of the trays to as narrow a taxonomic level as you can. And to do that, there are different ways, there are different approaches to learning to identify organisms. One is the picture and description, and that works for people who have a real, photographic mind. And one is the key, where it says, does it have jointed legs, or is it just a squishy thing? Or does it have a hard shell? And you say, oh, well, it's got jointed legs. How many jointed legs? Is it 6 jointed legs? Or is it 10 jointed legs? Or can you even count? Actually, they're couplets, so there are only 2 choices. I'm sort of riffing here. But both work. And then it says things like, are the paraglossy longer than the glossy? And so off you are to the races, where you have to go to the back of the book and say, what the heck is a paraglossy? And, it's just endless, endless, endless opportunities to learn if you have the right kind of geek. And I'm hoping you do. And then there are other exciting things about bugs. Which box did I leave that in? You can get a kid hooked up with using a microscope, maybe. That's actually not a microscope, it's a dissecting scope. It doesn't magnify as much, but you can still see plenty of cool stuff in it. So this world of bugs just opens the way up to a lot of things that people can learn. All right, so the next trick is for somebody, a really detail-oriented, mathy person who can get into watershed delineation. So these are topo maps. And what usually happens on the test is that somebody puts a dot on the topo map, like at the mouth of one of the streams, and says, okay, delineate, show me on the map all the area of land that's going to drain into that stream. And I have some descriptions of how to do that here. So what I have trouble with when doing it is using 2 sides of my brain at once. Because on one side of your brain, when you do a watershed delineation, you're backing out to see the general shape of the land. But on the other side, you have to look very carefully at the details and try and cross the topo lines as perpendicularly as possible. So if you focus too closely and are just looking at the perpendicular line, trying to hit the lines perpendicular, you wind up missing an entire valley that does come into your watershed. But on the other hand, if you just stay, you know, at 10,000 feet. And don't look at the line, sometimes you can make mistakes as well. So that's a kind of job for a kid who really wants to deal with details, but also see the big picture. All right, a third part of the test is actually doing water quality measurements, and we bring kits. I have brought the frequent flyers, but we don't say what kits we're going to bring up ahead. But just for example, this is pH. You mix the indicator with the water and compare the color to a chart and say what the pH is. This is alkalinity, and I just told you a little bit ago that one of my things is the difference between pH and alkalinity. This works by you drop water into, sorry, you mix the water with an indicator, then you drop acid into the mixture until it changes color. Who said chemistry wasn't fun? And this is turbidity, which is very simple. You pour the water on top of, into this tube and then put it on top of a card and see what the, see sort of the fogginess and which diagram your water makes the card look like. Sorry, that wasn't a good explanation. But that allows me to make this point. What the kids have to do is read the directions. They don't have to learn it, you know, because they've done it before. They have to read directions and carefully do them to try to get the right answer. And they'll ask during the test, "What the heck do you mean?" And people say, "Well, let's read that first sentence. You got that? Okay. Let's read the second sentence. Do you have that?" And I mean, the point is read the directions. And that's not to say that that's going to make it easy, because some of the directions are confusing. Yeah, some of the directions are confusing. The last one is stream evaluation. And this is something that is done all over the country. Basically, it's walking through a stream and identifying particular features that indicate whether that stream is getting a bunch of sediment from the stream banks or not, and whether the stream banks are falling in or not, and whether the habitat is good or not. And generally, if there's sediment coming in, the habitat is not so good. And I think the skill here, the kind of kid that you're looking for here, is somebody who will just say, that is a 3 on this scale, that's my decision and I'm going to go with it. I've put all the thought I can into it and it's time to go on. So, yeah, in that packet, I didn't pass out that packet yet. So you can see it's basically a data sheet. The stuff I want to draw your attention to is page 2 or 3. Especially, let's look at page 3. You can see 4 diagrams, and there's like clean gravel in the first one, gravel with a little bit of silt and sand around it, and then gravel that's getting completely taken up by silt and sand, and then a bottom that's covered with silt and sand. So you need a kid who can say, it's 14, and I'm sticking with that. And another kid will say, I think it's more like a 15. And the first kid will say, well, you can say that, but I think it's a 14. And basically, the kids need to settle on a number and pick it and go with it. And this is something that no 2 people agree on the first time, and no 2 people agree on the second time, but you know, after a long time, people start agreeing and getting more experience and seeing things the same way. Okay, so I don't think there's any more point in me talking. I can pour out some bugs if you like, or I can answer questions if you like, or I can draw lines on topo maps if you like, and if I'm lucky, and if anybody brought a pencil.
Let's see some bugs.
All right, so I'm not the bug guy from times in the past, so I don't know if I'm as good at keeping them alive.
Should they have learned this in school by now? What the bugs are?
Not all of it, no. I mean, they're definitely going to have to go to independent study mode. And I think that's why these people are heroes. Because they're going to start telling kids, you know, you're learning stuff in school, but what counts is also what you start up and put into it all by yourselves.
Is there a chart online that they can use to identify the insects?
Yes, and also in the thing I passed out, there's a number of links as well.
Do all healthy streams in West Virginia have these bugs?
There's, all over West Virginia, there are streams where there are some bugs.
Okay.
So you just spoke before I was going to make excuses about my poor selection of bugs. The guy who usually does this, Glenn, well, he knows a lot more than I do, and he lives in places with some more diverse streams than I do.
I just didn't know if they vary depending on what area you were.
They do, and it's an endless amount of study and record keeping that people do to figure this out. The Watershed Assessment Branch has monitored bugs in, I'll say, 1,000 or 2,000 streams, maybe 10. And they go through and they either pick out bugs, trying for at least 200 in each stream, and identify each one, and their taxonomic levels, kingdom, phylum, class, order, family, genus, species. So if I work really hard and spend some hours, I can get a lot of them to family, or order in case of the crustaceans, but family for a lot of the insects. The DE people, they get bigger microscopes and look at all their private parts and get it down to genus. And then they say, well, we'll look at the number of different families, and then we'll look at the ratio of sensitive ones to insensitive ones, and they go through a lot of math, and then they say, well, this one scored 77 on our score, and it's complicated. And they have to compare really good streams from Monroe County with really good streams or really bad streams from Wetzel County, and a lot of the organisms are different. But it's the pattern of biological richness that really they look at. And it's true for polluted streams, and it's true if you set up a gamma radiation source in the middle of the forest, that you see simplification. You see a cut down of the numbers, and a cut down of diversity, and a cut down of really sensitive species. That it seems to be sort of how biological richness works. When there's a stress, cuts down diversity in terms of numbers of different species, it cuts down overall numbers, and it cuts out the really sensitive ones. And it progresses until you started with a forest with 10 different tree species and you're left with lichen on the rocks. Or it started out with 5 kinds of mayflies, 4 kinds of caddisflies, and 6 kinds of stoneflies, and 15 other organisms until you're left with just midges or something like that. So they definitely can measure the pattern, although you can't say exactly what will be in which stream in West Virginia. Sorry, got on a soapbox there.
I didn't know.
Is this the exact data sheet they'll use when they do this?
Probably
portion
not.
of it?
Almost
Yeah, it'll
certainly
probably
not.
be simplified, everything.
It's an example.
Okay,
It's to give the idea of a data sheet.
okay. And they're only doing one of the chemistry kits as part of the contest. There will only be
Right.
one of them, or,
I think there is usually only one. There might be two.
oh, okay.
And as I say, these are frequent flyers. It could be anything.
Okay.
Lord knows what they're going to come up from Lamont or whatever when time comes around. And generally, we try to make a test that's interesting for the site where we are. So, yeah, pH, if we're in a limestone place, you know, obviously pH is going to be pretty high. I don't know if we pick that, but we might. Okay, come see some bugs. All right, one of my favorite questions is, we say bugs, but really we're talking about benthic macroinvertebrates. What the heck are those? And your kids will know, because you'll make sure they know.
They're bugs, right?
Yeah, it's a pretty good approximation.
You can see them without a microscope.
So for instance, I see two things in here that are not insects right off.
Oh, I didn't see them.
You want to pick one up and put one in a smaller container?
There's another one.
And put somebody in there and get a closer look.
We're just picking them up with our fingers.
Yeah, no, here.
Oh, thanks.
Yeah.
Oh, look at this little color right here. Do I put him, where do I put him?
You can put them in.
On here?
No,
No,
the one
in here,
without
then
the
this-
glass, and then you put the glass over.
Then you can see.
And I think it works better if you get a little water in there with it. And then here's some resources. We can make that a lot more effective with the light.
Oh, that's, I was just looking for a light on it.
Is this how it'll be set up? They'll have trays and they'll have just what we have, and they can take them out and ID them and have a key.
Yeah, they can have a key. We probably put one right there next to them.
Really?
Well,
Well, if they had something, like, is this provided?
I don't
or
know.
no way?
yeah, I think that's provided. I don't remember exactly. I'm usually the chemistry guy.
This is what they look like when you kill them and they don't move as fast. Just for the record, this is what a dead
Well, thank you, because
mayfly looks like. Sorry about that. Apparently he wasn't a fan of being mauled on the side to try and get in the container.
There's another one. Oh, you know what that is? I think that's a dragonfly. Yeah.
Yeah, it's a little creepy.
And the dragonflies are very cool because they have a jaw that hinges out, and then they catch things with the little thing coming out. I'm going to be embarrassed when I see that on film.
I did not kill that one. Oh, I had it for a second.
They're probably, so this is not their best day ever, as you can imagine. And I think in addition they're confused because they say, what the heck, I thought it was winter, because they've been in cold water. And now things are starting to warm up and there's light. They say, what's going on here? Global change.
Okay, well, catching bugs is not going to be my life gift here. Yeah, this is not enough going word for that.
Practice.
Well, you did everything I would have done.
Hang on, I can pinch me. Thank you very much, buddy.
See, now you're catching bugs.
Yeah, well, those are bigger. I caught those out of a collection box from the watering trough. I've done that. It's just those little ones. Oh, gotcha now.
Something that says, that is point A. Find me the watershed of point A. So it's important to back out and say, oh, okay, well, this looks like a ridge. That's pretty funny. It goes really, you know, a stream there and a stream there and very steep. But it makes sense because you can see these are
Elevation lines?
yeah, they're contour lines. I'm wondering if I should back out here and say that each of these lines, everybody know how contour lines work? Okay, yeah, so you see these little circles, they're going to be either the top or the very bottom of something when they're circles. And this, you can look at the numbers, say this is 1420, this is 1340, I guess they're the top, I guess that's a ridge. So you can see in general, okay, here's a ridge, there's a little funny there, better be careful, but it looks like here's a ridge. Here's a big flat area, but definitely the streams won't always be on the map. On this case they are. But definitely here's a funny little area, it's really flat, almost like an airstrip or something. But it looks like the dividing line has to go through here somewhere. No, then somewhere in here there has to be a ridge. It won't be in all this place of dense parallel lines, so probably you have to go up here somewhere. But it's not immediately obvious where you start getting those circular islands again. Well, here you do, and it looks like it's downhill all the way to there. And this looks kind of like a ridge. There's an island going to that island. All right, but we're going to have to be a little careful in this area. Then here's another ridge and some arms coming down. So that gives you the general idea. And then the trick is to make sure you're going straight up, perpendicular to as many topo lines as you can. Theoretically, it should be all of them, but life isn't always theoretical. All right, so I've come up this slope, thinking that if I'm perpendicular and I'm walking up, everything to my right will come down the hill, but it will come down the hill downstream of this point. Everything on my left will come downhill, but it will come downstream, upstream of this point, so I should count it. All right, so I've gotten up to the ridge. Now I'm walking along the ridge. And again, I'm walking along a ridge, so everything to my right will flow down this slope and go right into the river. Everything to the left will go down that slope and come into the stream that I'm concerned with. Right? So I tried to cross those perpendicularly, continue on the ridge. Excuse me. So often you don't cross perpendicular, you actually cross at the point, which makes sense. You know, a ridge, if you have a ridge that's sloping, then, you know, the topo lines are going to go like this. And again, you just keep going, making sure that the water on your right flows outside and the water on your left flows inside. All right, so this is one of those tricky detail areas. I definitely get to that little circle, which is a peak, but then is this going down or is that going up? If I look at these lines, I say, oh, well, I'm going up, now I'm going up some more. But if you look here, we're coming back to a lower area because there's a stream there. So I'm pretty sure what's going on is this is still the top of the ridge. And to be really sure, I'd want to like read all the numbers and say, okay, that's 1420, so this is probably 1440. All right, that's consistent with that 1440. This map is a little bit difficult because you can't see exactly which line the topo numbers are going with, but I think it'll tell you enough. All right, so I'm going to keep running out the ridge, going past these little circles that represent the top of the ridge. All right, looks like that's all a little holler going down to that stream. So I'm going to come out onto this bump. All right, now I have to get from here to there. And this is my favorite thing to explain to kids. It's a saddle, which is, it's high on two sides and low on two sides. See, it's high here and high here, but it's getting lower towards that stream and lower towards this stream. Okay, so again, you can move in and out, saying, well, I know this is higher than that, so it's got to come down one of these noses, but which nose? And it's hard to be sure from this one, but that's when you back out and you say, well, this is a little bit of a holler, but when it gets to this flat area, it seems like it'd be a lot easier to go that way than all the way down here. So I don't think that's the way it goes. Well, here's another nose. When it comes down this nose and gets to the flat area, it's easy for me to believe that it could go either this way or that way. So then it's a question of, do I go back up this nose or do I somehow cross over here? And there's no way to know for sure. And the best way to find out for sure is to walk there and see the land and see, oh, in fact, not only does it slope that way, somebody put a culvert in. But my best guess is that we're going to cross over here, maybe up there, and down this nose, up that nose. That doesn't sound very good. And then get back up on this ridge. All right, so there I am. And, you know, if I'm too focused on the small part, I may say, well, here I am on the top of a ridge. I don't want to turn right because I'm trying to enclose a small area. But in fact, it would be a mistake to turn left because this here is just a little thing that sticks out into the valley that we're trying to get. So you have to back out and say, oh, I gotta hook up with going down this way somehow. And then when you get to these slopes here, I think it's almost always a better idea to go up than down. So that's how I would do it. And you can check it out because the forestry and soils people are really good at that stuff too.
So is this exactly what our students will get? It's just a map and they have to show the water stream systems that are there and then show what you just did with
Right,
the
that, I
watershed?
forgot about that. They say draw in the streams too in the test. But yeah, that's the hard part is drawing in the watershed.
Yeah. And now, is it like an all or nothing point system? Like they get it, if they get this
I've never done the
completely
grading.
wrong? Yeah, okay. I'm just wondering, like, they're just off a little bit? Is it all wrong? Or is it partial points or?
Yeah, they give partial.
That's what I'm thinking.
Yeah, it's
right?
not all.
Everybody gets zero,
Yeah.
who's gonna get it 100%
Because it
right?
would be,
Yeah, it's not all or nothing.
really hard to determine.
So I can imagine that they would give leeway when you choose exactly what to do up here.
Yeah.
So we are standing, I think, I think we're standing about here. But people who know the area may know better. Put us on the map here? I stole your pen. Nice pen.
Yeah, this is a nice pen. Let me see where on that.
So this is a
That's the
flat
backwater
area,
from
almost
the
like an
dam.
airstrip.
I'm not sure we're on, but you probably should be on back over here in real life. Yeah, I think you're a little bit off the map.
I don't, well, all right, it could be.
Who knows?